All right, hello everybody. This is Nick, your TA for 123L, the online section, of course. So going over the grading for this week, it was apparent that a lot of you guys were struggling with this scientific graphing. Now, this is a real basic skill in the sense that it comes up again and again and again. It's not basic in the sense of being easy, though. Once you master it, it will feel easy. It really is one of those things that you'll just go, oh good, I just have to graph it. That's easy. But unless you realize some of the key concepts going on behind it, it can be a real pain. And this assignment actually was a really good brain teaser in the sense that it required you to make one key realization about the data and the graphing, and then it was amazingly simple. Like you'll really go, once I show it to you. But let's talk about it from kind of the very start, and we'll work our way up real quick, or as quick as I can. Okay, because I do want to talk about some basic concepts and misconceptions that I saw in the submitted work. Let's see here. So you guys should have gone through everything here in the module, right? And then you'll get down to these samples, which a couple people emailed me about because these are very thorough samples for this assignment. It was possible to do the assignment without a massive write-up, but if you did a massive write-up, you had better chance of getting points if you did something wrong. But I could see that you were very, very close, or on the right path. It's always a good thing to have that kind of explanation. Graphing assignment, this actual key part, right? So let's pull that up. Now, here is the key thing to know. Let's highlight. This is kind of the heart of the assignment, right? Use the data to make the graph. Here, let me zoom in so you guys can see it. There we go. A little better. Use the data to make a graph to determine the number of moles in the flask. So that is the question. Determine the number of moles of gas in the flask. So a lot of you just didn't actually answer that question. If you didn't answer that question, I couldn't give you a lot of points, right? Because that's kind of that's like not writing 2 + 2 = 4. You got to actually write 4. Got to actually tell me the answer. The other part here is you have to use the Excel program to make the graph, label the graph properly, and submit the graph with your answer for the number of moles calculated from the graph. This is another big part of it. And submit the graph with your answers for the numbers of moles you calculated from the graph. So that's a big hint. Apparently, you're supposed to be able to calculate the number of moles with a graph. That's interesting. What's the deal there? Be sure to show all work and calculations. That again goes towards that full detailed write-up. It's always nice. And anyway, then we actually gave you some data to play around with. So I'm going to download it here. And now, let's play around with this. Real quick, we'll go over some concepts again. So, pressure in ATM, in atmospheres, and temperature in Kelvin. This is actually really key. Note that it's already in Kelvin and not in Celsius, so we don't need to do any sort of conversion. That data is ready to go, and this data is ready to go. But is this all the data we were given? No. 2 other things are in that assignment prompt, which are really good to know. In fact, they're essential. Some of you already are going, oh, obviously. 250 milliliters, right? And we know R. R is a constant. So that's something we're given before we actually go into the problem. So let's put in 250. Now, immediately, you should be thinking a couple things are wrong here. One, I didn't label this in units. That's dangerous because if I don't do the units, I might leave 250 and not realize that what I need to do is to convert that to 0.25, right? Because now, what's 0.25? That's in liters, okay? That's what we want it to be in. So what I would do is I'd do something like volume, if I could spell, liters Can't type today. And then I'd put 0.25. Right? A lot of people did this, and that was excellent. That you're doing everything right there. And then we have to get R. Here's another one, though, that's actually kind of funny. Because a bunch of you may have done this. Let's go look up R on the internet. All right? And so if we look up R, the gas constant, we can pull up a wiki page. And of course, I mean, you guys have all had the conversation about wiki a million times. I'm not going to talk to you about that again. But we can go there and get a list of its values. Now, why is it a list and not one value? Isn't it a constant? Yeah, but we can compute R for various different units. Right? So we have all these different combinations of units that give us pretty close values or wildly different values. I mean, 8.3 is so different than 5.18 times 10 to the 19th. These are totally different, ballparks here, right? So it's key that you identified which R to use, right? If you're using a chemistry textbook because you're enrolled in that chemistry main course currently, then that book has an R value. And it may have more than one as well. And again, the key is to make sure that the units match. Okay, so what do I mean by that? Well, let me see if I can draw this for you guys. This is going to be an experiment. We'll see how it works. So what's the equation we're using this week? P V equals N R T, right? Now, this means whenever we see equals, right, this side is equal to this side. And we always think about that numerically, like 1 equals 1. But it also means that 1 mole equals 1 mole, or 1 ATM equals 1 ATM. See, so the units have to be equivalent and work out as well. So here, we are talking about P in ATM, right, times volume in liters is equal to N, which is going to be in moles, right, because that's what it's supposed to be, times R, which has many different combinations, times T, which needs to be in K. Good old Kelvin. Okay? Now, what are we solving for? Remember, the question was solve for N, right? So we want to solve this equation for this guy. This is basic algebra. Everyone looked like they were on board with this. I'm just going to rearrange it, and we can get N is equal to PV divided by RT, right? So that means that's going to be pressure in ATM times volume divided by temperature divided by R is all supposed to give me something in moles. So everything has to cancel out except for the unit mole and some number. Okay? So I have to pick the R that's going to cancel out all of those values. And in this case, the right answer for doing that was using this 0.082 number, okay? Because that has liters ATM per Kelvin mole, right? So the liters and the ATM cancel, and the Kelvin cancels, and you're left with mole, just what we want, okay? So that's going to be the value for R that you're going to want to use. Let's pop that in our chart. I'm actually not going to type all the units here, but you guys should just to save time. I'm not going to do that now. Right, so who here had an epiphany when I drew this on the screen? Because this was actually the key to the assignment. This N equals PV over RT. Why do I say that? Well, what does this remind you of? PV over RT. It's a fraction, right? Okay. What do fractions have to do with graphs? Well, basic relationship you want to be aware of, slopes are essentially fractions, right? You guys remember from basic algebra, rise over run, right? So here we are. Here's our rise. Here's our run. And there we go. It's starting to put it together. So what we need to do is we can create a column. There's multiple ways to do this, but this is the way I think makes the most sense. We're going to do PV, and we're going to do RT, okay? And then here, let me zoom in again so you guys can see all this. All right. So we just go, insert a formula. Now, I don't know how you guys like to do this, but the way I like to do it is select a cell, then I hit the equals key. And then the equal key lets me start typing in a formula and selecting. So what I did is I said, this is RT, right? So here's R, bam, and then it's going to be multiplied by T, right? Easy peasy. One thing that's worth noting, and this is kind of an advanced option, is that you want the D2 to stay. Okay? Now what I mean by that is I'm about to drag down this column. And what you'll see here is that it does all the math for me, right? But if I hadn't put these dollar signs in the middle of D2, it would have also tried to multiply the numbers with all the numbers that were in these cells, which are obviously blank. Would have given us bad data and just wouldn't have worked. So you kind of have to do that just to make sure the actual graphing works. This is just kind of Excel basics. Anyway, we can now do the same thing for PV, equals, pressure, right, times, I'm going to use a shortcut, times, I don't know if you guys noticed that they both switched the dollar sign there. That's just because there's a shortcut, F4. You can do that to make it go quicker. Anyway, drag that down. Unless I missed. Doing Excel on camera is kind of like a awkward exhibit. All right, let's see here. So now we've got RT, PV. Guys, the assignment's almost over. Now what we have to do is select these two columns, okay? I do this, by the way, with shift clicking. So you can click a column, then hold the shift button and click somewhere else, and it'll select everything, okay? Again, Excel basics. So F, Shift, G, bam, all our data is good. Now let's go over and let's insert a chart. Okay, this is the graph. This is kind of the essential, what are we actually doing here? It's all about the graph, right? So let's insert it. Insert graph. We're going to come over to these charts, and we want a scatter, okay? Now you notice there's these different versions. All right, you know, cool stuff. You actually can really select any of them at this point, because then we're going to edit the details of that until it becomes the chart we want, okay? So I'll select this one. One thing that's really nice to know, at least in modern versions of Excel, I don't know if this is true in older ones, is that now that we've done that, notice how our bar has changed, okay? Up here you see quick layout. And this gives you all these different options for like standard layouts. It just can save you a different time, because there's one on here which actually inserts a trend line for you. And that means that it gives you this formula. Right, and that's one of these basic things that's going to come up again and again and again and again. Please give me a formula for your data, right? That's going to pop up. Anyway, there's a trend line. We can get rid of parts because I actually don't need this legend, right? That's unnecessary. And then what you guys would have done is labeled your axes, right? So you would have labeled this one RT, and you would have labeled this one PV, right? And you should always label them as completely as possible. So you probably would want to put the units of PV. You know, you'd want to put the any sort of kind of context that needs to be known to understand what's going on. Of course, I'm trying to save time here because I'm already going long. But for your homework, that's what you're going to want to do. Okay. Oh, that's hideous. Let's move this. That's another thing to keep in mind, by the way, kind of basic readability. There were some graphs where people had like all of the data on top of itself, like you just in a big pile. And I actually didn't mark down for it, but this week. But in the future, if your graph comes out and just is absolute mess, it's a problem. All right. Anyway, so let's click on this trend line, and we're going to go to Format Trend Line. Let's just right click, right? Now this is important because the trend line by default tries to be the perfect line. And that means it's trying to get the R squared to be a nice value, and it's just trying to match the data. But it also can come up with kind of random conclusions. So in this case, it's important for us to set the intercept to 0. The y-intercept. Again, the basic algebra. We're setting the y-intercept of a linear line, y equals mx plus b. We're setting the b to 0 manually. Okay? That will give us the most accurate n. Okay? And then what we're going to get out of that is a nice little graph of y equals 0.1049x. There you go. 1049x is equal to n, right? That comes right back to this concept because we graphed PV over RT. We graph PV versus RT, and that means that's what our slope is going to be. It's going to be rise versus run. It's going to be n. So our slope is PV over RT. So it actually is already doing the math for us. And that's kind of that key that you could have had when you're doing this assignment. Because if you realize this, you realize that's it. That's the assignment. You've now calculated n. Now again, the key answer is the key step here is now that you have the answer, actually write this somewhere, right? Like don't just leave it here. You need to put it down here somewhere, which is like n equals blah, right? Tell me the actual answer to the initial question. You have to do that, okay? Now, you could do this in the Excel. You could have attached it in a document file, like a Word file, whatever. But you actually have to somewhere say, here explicitly is the answer. Now, note that one of the things I didn't actually have to do was go through and compute every single mole for like every piece of data. I didn't have to go through here and crunch numbers on my calculator and go, okay, this times this divided by this times this is equal to type it, right? That's a pain. This saves you from doing all of this. All we have to do was drag a couple boxes down, click a couple things, and say insert chart. Bam! Done. Now, there were other ways that you could do this that aren't quite exactly on top the point of the assignment, but they showed a lot of the key concepts, so I was pretty okay with them. For instance, one of the things to do is just use Excel itself to put in an Excel formula so that you can compute the moles for every single value, right? So since I already computed PV and RT, I can do that. I could just hit equals PV divided by RT, enter, right? And then, bam. Again, I can drag down. Voila. Right? Now, another cool trick. I don't know if you guys know this. You can hit equals average. See how it actually says average there? So if you hit tab, then it says, what do you want me to average? I want you to average this column, Excel. Boom. It gives me an average value. I mean, really that simple. And again, this would have given you the right value for n. If you guys have questions about this, shoot me an email and I'll try to answer. Remember, come to office hours. I've got those online office hours. I can always try to schedule in-person office hours if you need it. Anyway, good work. We'll try to get better and better as the semester goes on. Have a great weekend. Bye.